Hey everyone, and welcome to another deep dive. Today we're going to be really diving deep into a paper that I think has been incredibly influential.
Yeah.
It's called Attention is All You Need.
Yeah.
And
Really exciting stuff.
really excited. We're going to be talking about the transformer model. And this is a paper that really revolutionized, I think, how we think about natural language processing.
Yeah, absolutely. I mean, it's one of those papers where you can really see a before and after
Right.
in the NLP space, and
That's
even beyond NLP now.
Yeah, yeah. And this is a paper that came out in 2017. And we're recording this a few years later, and we can see the impact. Like, this is not something that,
Oh, that's right.
people were maybe a little bit slow to catch on to or whatever.
Total.
But yeah, so to kind of give people a little bit of background, before this paper, I think the big thing in sequence modeling was recurrent neural networks.
Yeah, definitely. LSPMs, GRUs.
Yeah.
That was the name of the game.
Exactly. And so if you were working with text or speech or anything that really had that sequential nature to it,
Time series.
RNNs were the thing.
Time
Nice
set.
series, yeah. But they had their limitations. I think the big one being that they were just really hard to train on long sequences.
Yeah, and it's really intuitive, I think, why that is.
Yeah.
Because you have to go through and process each piece of the sequence in order.
Right?
It's like if you have a really long sentence, you're going through that sentence word by word,
Yeah.
and by the time you get to the end, who knows what you're remembering from the beginning?
Yeah, exactly. And so that's one of the things that I think is so brilliant about this paper is that it just completely throws that out the window.
Yeah, throws it out the window.
It's like, we don't need recurrence. We don't need convolutions.
Yeah, it's a completely different way of thinking about it.
Attention is all you need.
Exactly. And it's funny because now,
Isn't that the title of the paper?
and that's the title of the paper, but now it's so ubiquitous. Like you see attention in everything.
Yeah,
But at the time, it was this huge shift.
totally. So let's maybe talk a little bit about attention. What is this attention mechanism and why is it such a big deal?
Yeah, so I think the easiest way to think about attention is kind of like when you're reading a sentence.
Yeah.
You're not paying equal attention to every single word in that sentence.
Right.
You're focusing on certain keywords, certain phrases, and those are the things that are giving you the most meaning.
Yeah, so it's like you're kind of weighing
But
the
yeah.
importance of different words
Exactly.
in the sentence.
Exactly. And the model's able to do that too. It figures out which parts of the input are the most important to pay attention to
Right.
in order to make its predictions or generate its outputs.
So if you were translating a sentence, for example,
Yeah.
from English to French,
Right.
the model might pay more attention to the verb or something.
Exactly. Or maybe like the subject of the sentence.
Or, yeah, or if there's some sort of like
Yeah.
idiom or something, it might pay more attention to that because it knows that that's going to be really important to getting the translation right.
Totally.
Okay, so the authors of the paper, they actually give a really, I think, helpful diagram.
Figure one.
Yeah, figure one. I always love it when papers do that. They give you,
Visual.
yeah, a little visual. And they call this the encoder-decoder structure. So maybe we can kind of like walk through that a little bit. What is this encoder-decoder structure?
Yeah. So think about it this way. The encoder is kind of like the understanding part of the model.
Okay.
It's taking in the input, let's say it's that English sentence, and it's trying to figure out what does this actually mean? What are the important parts? And it's creating like a representation of that sentence.
Okay.
The decoder then takes that representation that the encoder created
Okay.
and uses it to generate the output. So in the case of translation, it would be generating the French sentence.
So the encoder is kind of like taking things
Figuring out,
apart
like analyzing,
and
yeah,
analyzing it.
Yeah.
And then the decoder is taking
putting it back together
those like constituent parts and then like rebuilding it
in a new way
in a new way.
based on the task.
Yeah, that makes sense.
So it's a really elegant architecture.
It is elegant. Okay, so we've talked about attention. We've talked about the encoder-decoder structure. But there's another really key piece to this, which is this idea of self-attention.
Right. Right.
So what is that?
Yeah, so we talked about how attention is kind of like focusing on the important words in a sentence.
Right.
Self-attention is basically doing that, but within the sentence itself.
Oh, okay.
So it's not just looking at one word in isolation.
Right.
It's saying, how does this word relate to all the other words in this sentence?
Interesting.
And by doing that, it's able to capture these really long-range dependencies,
Oh, okay.
which, again, RNNs really struggled with.
So it's like it's almost like the model is able to understand the sentence as a whole.
Exactly.
Rather than just
It's
sort
at the
of
context,
word by word.
the whole context, yeah,
Yeah.
which is really cool.
That's really cool. So we've talked about how this model works at like a high level. But one of the things that I think is really important to emphasize is like,
Yeah,
it's not just that it's like a cool idea.
right.
It actually leads to like significant performance
Oh,
improvements.
absolutely. Yeah,
And the authors of the paper, they give some really striking numbers
they do.
in table 1.
Yep. I was just looking at that.
And so like
Yeah.
without getting too much into the weeds,
Right.
they show that the
Yeah.
transformer is like
Significantly?
way more computationally efficient
Yes.
than previous models.
Yeah, and that's huge because it means that you can train these models faster.
Right.
You can train them on more data,
Right.
which ultimately leads to better performance.
And it also means that you can train them on longer sequences,
Yes, absolutely.
which is something that we've talked about
Which is the original problem.
that RNNs really struggled with. And so it's like it's solving these
It's addressing it directly.
really fundamental
Yeah.
problems in the field.
Absolutely. And I think the other thing that's really important about that is that it makes this technology accessible to more people.
That's a really good point.
Because before, you needed these massive
Yeah.
data sets, these huge clusters of computers to train these models.
Google scale data.
Exactly.
Yeah.
And now with the transformer, even with like a more modest setup,
Right.
you can still get really impressive results.
So it's like democratizing
Exactly.
access to this technology.
Exactly, which is really exciting.
That is really exciting. Okay, so
Yeah.
we've talked about the architecture, we've talked about self-attention, we've talked about
Yeah.
the computational benefits, but how did it actually perform?
Right. The million-dollar question.
Yeah, like when they actually put this to the test,
Yeah.
how did it do?
Well, they tested it on a bunch of different benchmarks,
Okay.
but one of the most impressive was machine translation,
Okay.
which is a notoriously difficult task in NLP.
Yeah, and actually something that I've always found really
Yeah.
fascinating because it seems like it's so nuanced.
It's so nuanced. Like,
Yeah.
how do you actually get a computer to understand, like,
The subtleties.
the subtleties of language? Like, it's one thing to be able to, like,
Yeah.
translate word for word, but to actually capture
The meaning. The tone.
the style.
The style, yeah. It's like,
It's incredibly difficult.
it's almost like an art form in and of itself.
Absolutely.
Mm-hmm.
And so they tested it on this really tough machine translation benchmark.
Okay.
And the results were mind-blowing.
Okay. Tell me more.
So they were working with English to German and English to French.
Okay.
And the transformer just blew everything else out of the water.
Really?
Yeah, like it wasn't even close.
Wow.
It outperformed all the existing state-of-the-art models.
Wow. So, like, what were those other models? Like, what were they comparing it to?
So at the time, like RNNs were still
Yeah.
kind of the gold standard,
Yeah.
but people were also using things like convolutional neural networks for machine translation, and they were also using these really complex ensemble models.
What's an ensemble model?
Yeah, so an ensemble model is basically like you take a bunch of different models,
Okay.
you combine them together,
Okay.
hoping that like the strengths of one model will make up for the weaknesses of another.
Okay. So it's like
It's a very brute force approach.
it's like a team effort.
It's a team effort.
Yeah.
Exactly. And even those really complex ensemble models,
Yeah.
the transformer still outperformed them,
Wow.
which is really saying something.
That is really saying something. So not only is it more computationally efficient, but it's also
And more accurate.
more accurate.
Yeah.
Wow.
Which is like the holy grail of machine learning.
Totally. Okay, so
Yeah.
I'm starting to see why this paper is such a big deal.
Yeah.
But I'm curious, like, were there any limitations? Like, did they find anything that it wasn't good at?
That's a good question. I mean, like any model, it's not perfect.
Right.
One thing that they did mention is that at the time, it was still pretty computationally expensive to train
Okay.
compared to like
Okay.
a simple model.
Right. It's all relative. Right.
Exactly. But even that has kind of been addressed
Right.
in the years since with like new hardware and stuff.
New hardware, new techniques.
Exactly.
Yeah. Okay. So it sounds like even the limitations that they identified
Yeah.
have kind of been
Address.
addressed in the intervening years.
Exactly.
Wow. Okay. So we've talked about machine translation. Did they apply it to any other tasks?
They did. They were really interested in seeing, we've conquered machine translation.
Right.
Can we push this further? Can we apply it to other NLP tasks?
Yeah.
And one of the tasks they looked at was something called constituency parsing.
Okay. Constituency parsing. I'm going to
Yeah.
be honest. I'm not familiar with that one.
Yeah, so constituency parsing is basically like taking a sentence
Okay.
and breaking it down into its grammatical constituents.
Because it's like diagramming a sentence.
Exactly. Like you did in grade school,
Yes.
where you have like the noun phrase, the verb phrase,
Right.
and you're like drawing the tree.
Yeah.
That's constituency parsing.
Okay. So it's like
The
understanding
structure.
grammatical structure of a sentence.
Yes.
Yeah.
Okay. Got it. Got it. And so how did it do on that?
It actually did surprisingly well, which is really interesting
Yeah.
because it suggests that the transformer is able to learn these
Yeah.
hierarchical relationships
Wow.
within a sentence.
Right. Which is not something that you would necessarily expect.
Right. Because it's not explicitly trained to do that.
Right.
It just kind of learns it
Wow.
emergently.
That is wild.
Yeah. And that's one of the things that I think is so exciting about this model is that
Yeah.
we're still discovering
Yeah.
new things that it can do.
It's almost like it's learned something fundamental
Yeah.
about language.
Exactly.
But we didn't even know was there.
Exactly. And it's able to apply it to all these different tasks. That is so cool.
Isn't it?
It really is. Okay,
Yeah.
so they tested it on these 2 NLP tasks,
Yeah.
machine translation, constituency parsing. Did they try anything else? Or were they just like, you know what, we're good?
Well, they did hint at some potential future applications. Remember, this was 2017.
Right,
So they were really just scratching the surface.
right.
But they talked about how this attention mechanism
Yeah.
could potentially be applied to other domains beyond NLP,
Oh, interesting.
like computer vision,
Okay.
speech recognition,
Right.
even things like time series analysis. So they really saw this as
Yeah.
a general purpose framework.
It's like a new way of thinking about
Exactly. A
things.
new way of thinking about intelligence even.
That's amazing.
It is pretty amazing.
And so I guess the question is, 5 years later,
Right.
have we seen
Yeah.
that vision come to fruition? Like, have we seen attention used in all these different...
It's everywhere.
It's
everywhere you look in AI now.
Wow. Okay, so we've covered a lot of ground, but I think it's safe to say that this paper, Attention is All You Need,
Yeah.
really did live up to its name.
Really did.
It introduced a powerful new architecture, the transformer, that has had a profound impact on the field of AI.
Absolutely. It really did put machine translation on the map in a big way.
So, like, how much better did it actually perform? Like, give me some numbers.
Okay, so on one of the benchmarks they used, which was, like I said, English to German and English to French,
Right.
the transformer achieved a BLEU score that was like 2 points higher.
2 points.
2 points higher than previous state-of-the-art, which in the world of machine translation is like
That's like...
a landslide victory.
It's like breaking the sound barrier.
Exactly. And what's even crazier is that it did all of this while using significantly less training data than the other models.
Okay, so not only is it more accurate, it's also more efficient.
More efficient, exactly. Which is, like I said, the holy grail. We
Yeah.
want models that are both accurate and efficient.
So it's like it's not just learning how to translate.
Right.
It's like it's learning how to learn...
It's learning something deeper
Yeah.
about language itself. Like it's able to generalize
Right.
from a smaller number of examples.
Right.
Which is really exciting.
That is exciting. Okay, so we've talked about machine translation.
Yeah.
They achieved these amazing results. But I'm curious, did they just stop there, or did they try applying it to other tasks?
No, they didn't stop there. They actually, they took this new architecture, this transformer,
Right.
and they were like, let's see what else we can do with this thing.
Okay.
Let's see if this attention mechanism, if it's really as powerful as we think it is.
Right.
And so they decided to apply it to this task called English constituency parsing, which sounds very fancy.
It does sound very fancy.
But it's
I have a feeling it's not that complicated.
It's not as complicated as it sounds. Basically, it's about understanding the grammatical structure of a sentence.
Okay.
So like you were saying before,
Right, like diagramming a sentence.
diagramming a sentence,
Ah.
identifying the noun phrases, the verb phrases, all that stuff.
Got it. And so how did it do on that?
So it actually did surprisingly well on this task,
Really?
especially considering that it wasn't explicitly designed for this.
Right.
And what's really interesting about that is that it suggests that the transformer is able to learn these hierarchical relationships within data
Okay.
without being explicitly told to do so.
So it's like it's learning the rules of grammar
In a way. Yeah.
without actually being taught the rules of grammar.
Exactly. Which is kind of mind-blowing when you think about it.
That is mind-blowing.
Because it suggests that
Yeah.
maybe there's something fundamental about this attention mechanism
Right.
that allows it to learn these structures
Right.
that we haven't even fully grasped yet.
So it's almost like it's learned something that
Yeah.
you don't even fully understand.
Exactly, and that's what makes it so exciting, I think.
Yeah.
Because it suggests that there's still so much more to explore here.
So they've kind of opened up this whole new...
It's like a new frontier of
Yeah,
research.
okay, so they've shown that it works for machine translation.
Right.
They've shown that it works for this constituency parsing.
Right.
Which is already, like,
Which are both very different tasks.
very different tasks.
Yeah.
Did they have any other, like, grand visions for where this could go?
They did. So in the paper, they actually have a whole section
Okay.
where they talk about potential future applications.
Yeah.
And this is where I think it gets really interesting.
Okay.
Because they were already starting to think beyond just language.
Okay.
They were thinking about how this attention mechanism could be applied to things like computer vision,
Okay.
speech recognition, even things like time series analysis.
So, like, analyzing stock prices or
Exactly.
weather patterns or...
Exactly. Any kind of data that has a sequential nature to it,
Right.
they thought that attention could be applied to that.
So it's like they weren't just trying to solve,
Right.
like, a specific problem. They were trying to, like,
They were trying to find
develop a new...
a new paradigm
Yeah.
for AI.
That's really cool. And I think that's a good place to stop for today. So they had this, like, grand vision,
Yeah.
and it sounds like they were really onto something.
They were ahead of their time in a lot of ways.
Because now, I mean, you see attention everywhere.
Everywhere you look. Like you said, it's in our phones, it's in the
Yeah.
apps we use every day.
It's almost like it's become like this invisible force.
It's become an integral part of
Yeah.
the AI landscape.
That's shaping so much of our world.
And I think one of the most striking examples of that is
Yeah.
the rise of these large language models that
Yeah.
we've seen in recent years.
You're talking about, like,
Like GPT-3,
right.
BERT,
Yeah.
LambDA, all these models
Yeah.
that are able to generate,
The ones with the cool names?
yeah, the ones with the cool names,
Yeah.
that are able to like generate human quality text.
Right. Have conversations.
Yeah, it's almost like they're,
It's eerie
yeah, it's a little eerie.
how good they are.
It's like, are you a person or are you
Right.
a computer program?
And those are all built on this foundation
Really?
of the transformer, of the
Wow.
attention mechanism.
So this paper is really,
It's like the seed
yeah,
that grew
it's
into
amazing.
this whole forest of AI models.
That is really cool.
It is really cool. And it just goes to show you that sometimes these really fundamental ideas
Yeah,
can have these ripple effects
right.
that we can't even imagine.
It's like that quote, the most powerful force in the universe is compound interest.
I like that.
It's kind of like that, but with ideas.
Exactly. Ideas can compound too.
And it seems like that's what's happened here
Absolutely.
with this idea of attention.
Yep. And it's exciting to think about
Yeah.
where it's going to go next. Because
Yeah, where is it going to go next? What's the next frontier?
that's the big question, isn't it?
It is the big question. I mean, we're already seeing people apply attention to all sorts of things beyond just language and computer vision,
Like what?
like drug discovery,
Bring away.
robotics.
Interesting. Even things like climate modeling.
Wow, so it's really
kind of revolutionizing.
it's like this universal tool
Yeah, it's a universal tool.
that can be applied to all these different
And
domains.
I think the really exciting thing is that
We're-
we're still just scratching the surface of
Yeah.
what it can do.
Like we're just starting to understand
Exactly.
the power of this idea.
And who knows what amazing applications
Yeah,
we'll come up with in the years to come.
it's an exciting time to be in AI, that's for sure.
Absolutely. It's never been a more exciting time.
Well, on that note, I think that's a good place to wrap up our deep dive into attention is all you need.
Yeah, thanks for having me. That's been fun. Thanks for joining us. And to all our listeners out there, be sure to check out the show notes for links to the paper and other resources so you can dive even deeper into this fascinating topic. Until next time.